In this video, we are going to solve the following series using the integral test. This is a series we are told and we are given to solve using the integral test, which is a series as n is equals to 1 as it goes to infinite, 1 over n squared plus 1 multiplied by arctan n. When you look at this series, we'll see that there will be need where we will be needed to know what arctan 1 is and arctan infinite is. So let me show you the two important details we need to know before we start solving the series. The good part about this question is we have been told already to use the integral test. So we don't have to prove either this series is decreasing or it's positive or either it's continuous. They have already proved that for us. All we just need to do is to solve. So first thing first, what is arctan infinite? What is arctan infinite? Now we'll put a limit here. I'll say x as it approaches what? Infinite. Then let me just replace this infinite with x. Let me replace that infinite with x. So now the limit as arctan x, as x is approaching infinite, we need to find this value, which means we are plugging in infinite for x. X is approaching infinite. Then the other important thing which we need to know is the limit as tan x. When does the limit of tan x equal to infinite? The limit for tan x equal to infinite. Now the question that we are going to ask ourselves, what is x? Let me explain this for you. Let me make it make sense for you as well. Look at this. We want to find the limit of arctan x as x approaches infinite, what it is, isn't it? Now we can use the limit of tan x, which will give us infinite, because whatever value we are going to get for x as tan x will equal infinite. Now as x will approach infinite, for the limit of arctan x, it will be the same value we are going to get here. So let me show you in the following trigonometric graphs. There is this one, the first one. The first one is the graph. It's a graph for arctan. Then the second one is the graph for tan x. So I'm just going to write this 90 degrees. Now look at this. This is 0. This is 0. Now look at this. The graph of tan x approaches the 90 degrees line. 90 degrees line, it approaches the 90 degrees line and it goes up to infinite. It goes up to infinity as it approaches the 90 degrees line. So for the graph of tan x, for it to equal infinite, it is approaching what? The graph of 90 degrees. So x has to approach what? 90 degrees for tan x to equal what? Infinite. Now what is 90 degrees in radians? It is pi over 2. So now the limit of arctan, the limit of what? Arctan as it approaches what? Infinite. As x will approach what? Infinite. It will equal to what? This value which we have here, which is what? Which is pi over 2. This is where it will come from. Now, for tan inverse or arctan inverse of 1, you can just punch it on your calculator. It will give you the answer. It will bring for you the answer, which is pi over 4 or 45 degrees. So it is going to give you 45 degrees if you are using it in degrees, and it is going to give you pi over 4 if you are using it in radians. Now, since we have known this, since now we know this, we can come and try to solve this. So we are going to solve this using the integral test. The integral test will take our bounds. As n is equals to 1, this is going to be our lower bound. As it goes to what? Infinite, which is going to be our what? Our upper bound. 1 over, and see what I'm going to do. I'm going to replace wherever there is n with x. So this is going to be x squared plus 1 multiplied by arc tan x. You could solve them as the way they are using n, but it is more convenient for most people to use x, because we are mostly used integrating with respect to x. So I'm going to say dx. Now, the other question we need to ask ourselves is, how can we integrate these two functions? How can we integrate this whole thing? So the first thing I'm going to do is I'm going to say the limit, as I'll pick any value. I'll say b as it approaches what? Infinite. So I'm going to replace that with b, infinite with b, since now b is approaching infinite, and that was where infinite was. 1 over 1 x squared plus 1 arctan x. Now, how can we integrate this whole human being? The first thing we need to observe and ask ourselves, can we use u sub for this? We can use u sub if we can manage to cancel out the terms for x and let this be in the u world. So let's ask ourselves, if we assign this to be u, when we differentiate this, are we going to get this? No. So it means if this is u, it can't cancel with this. We can't cancel the x. But if we assign arctan x to be u, when we differentiate arctan x, we are going to get tan squared 1 over tan squared plus 1. So it might cancel with this. So let's assign. Let's say if our u is equal to arc tan x, du will be 1 over x squared plus 1 dx. Now, we want to find the dx because we're having dx in our question. So let's make dx the subject. So x squared plus 1 du. So now let's write what we have. Let's write what we have. We are going to integrate 1 over x squared plus 1. Then arctan is now u. Now what is dx? Dx is the same as x squared plus 1 du. You can see that this and this is cancelling. What we are just having is du over u. Now we have taken our whole function in the u world. Now we are going to first not write the bounds. We can either change the bounds, these bounds, into the u world. We take them into the u world as well, or we can just not be writing them until we will reintroduce back the x term. It is going to make sense as we are going. Now our integral will look like this. Our integral will turn up to be like this. Now the only question which we need to ask ourselves now is, what is the integral of du over u? The integral of 1 over u. This is the same as ln of u. Now a question, what was u? U was arc tan x. So this is the same as the ln of arc tan x. Now we can bring back our bounds. We can say we had b, I'll say b, we had our lower bound 1, put it here. Now this was a limit of b as it was approaching what? Infinite. Now what do we do? What do we do when we have these? We have two bounds and we have found the integral we wanted. So we are going to say the integral of arc tan, the upper bound, which is b, minus our integral, which is ln of arc tan. Now arc tan what? Arc tan 1. Arc tan 1. Now we have to ask ourselves a question. Ln of arc tan. Now what is b? B is infinite, minus ln of arc tan 1. This is where we have reached so far. Now remember, this is the ln. Now what is arc tan infinite? So for arc tan to approach infinite, as arc tan is approaching infinite, this will give us pi over 2, then minus ln of arc tan 1. Arc tan 1, the calculator would tell us it's 45 degrees. 45 degrees in radians, it's pi over 4. Now let's take cautious on this one. Ln of pi over 2 minus ln of pi over 4. Now the properties of ln, when they are subtracting, it means these the baby functions, they can divide. So this is the same as ln of pi over 2 divided by pi over 4. Now this is the same as ln pi over 2 multiplied by 4 over pi. So this pi and that pi will go, 2 here will go, 2 there will go, we are going to remain with 2. So this is the same as ln of 2. Now this is the answer I have found after using the integral test. And you just need to know very two simple things. For the integral test to give you a divergent series, they just need for you to find two answers. When you find negative infinite or positive infinite, it means the integral test is divergent, which will make the series to be what? Divergent. If you won't find any of the two, it means that the series is convergent. So what it means, if you are finding numbers which are not infinite, negative infinite or positive infinite, or not imagine, and they are not imaginary numbers. You're finding natural numbers, my decimal numbers, positive, negative numbers. This, the integral test, if you are finding numbers which are just numbers, either they can be negative, positive, decimal, fractions, it means that the series is what? Is convergent. Since now we found the ln of 2, ln of 2 of which, if I use my calculator, ln of 2 is the same as 0.693. It means this series is convergent. So the series, the final answer is the series was convergent. Thank you for watching, and if you haven't subscribed yet, hit that subscribe button so that you don't miss out on future videos. Thank you.